Hi guys, this is AS Chemistry, moles and molar ratio. Question 1. Which of these samples of gas contains the same number of atoms as 1 gram of hydrogen? So 1 gram of hydrogen is having an AR value of 1, whereas here they've given an MR of hydrogen gas as 2. So this is the catch that we need to identify in this question. So if we calculate the number of moles of hydrogen atoms, and we calculate the number of moles of each of these gases, whichever gas has the same number of moles as that of hydrogen will be the correct option. So for hydrogen, it will be mass upon AR. So mass is 1 gram. AR of hydrogen is 1. We end up with 1 mole of hydrogen atoms. So for carbon dioxide, the mass given is 22 and the MR is 44. So 22 upon 44 gives us a value of 0.5 moles, making this option incorrect. Next, we have 8 grams of methane and the MR of methane is 16. So 8 upon 16 is 0.5 moles again, which makes this option incorrect as well. The third option has 20 grams of neon having an AR value of 20. So 20 upon 20 is 1 mole, which is the correct option here. And the last one, we've got 8 grams of ozone. So 8 upon the MR of ozone is 48, gives us 0.167 moles, which was bound to be incorrect because option C is the correct option for this question. Question 2. On collision, airbags in cars inflate rapidly due to the production of nitrogen. The nitrogen is formed according to the following equations. How many moles of nitrogen gas are produced from 1 mole of sodium azide? So, according to the first equation, 2 moles of sodium azide produces 2 moles of sodium and 3 moles of nitrogen. Therefore, 1 mole of sodium azide would produce 1 mole of sodium and 1.5 moles of nitrogen. Now, the sodium is important here because this sodium is used in the second equation to produce more nitrogen. So in the second equation, 10 moles of sodium produces 1 mole of nitrogen, whereas we have 1 mole of sodium being produced in the first equation, which would produce 0.1 moles of nitrogen. So in total, the number of moles of nitrogen produced with 1 mole of sodium azide is 1.5 moles in equation 1 and 0.1 moles in equation 2. So adding these two together, we have 1.6 moles of nitrogen gas being produced in these reactions, making option B the correct option for this question. Question 3. The combustion of fossil fuels is a major source of increasing atmospheric carbon dioxide with a consequential rise in global warming. Another significant contribution to carbon dioxide levels comes from the thermal decomposition of limestone in the manufacture of cement and of lime for agricultural purposes. Cement works roast 1,000 million tons of limestone per year, and a further 200 million tons is roasted in kilns to make lime. What is the total annual mass output of carbon dioxide in million tons from these two processes? So, the first thing we need to do is write the equation for the thermal decomposition of limestone, which is calcium carbonate. So, calcium carbonate on heating produces calcium oxide and carbon dioxide in the molar ratio 1 is to 1. So, the MR of calcium carbonate is calculated to be 100.1 and the MR of carbon dioxide is 44. So 100.1 grams or kilograms or tons or million tons, all would be the same. So let's consider million tons because we are doing million tons in this question as asked. So 100.1 million tons of calcium carbonate produces 44 million tons of carbon dioxide. So the amount of calcium carbonate that is roasted per year is 12 100 million tons. So we need to find out how much carbon dioxide is produced. So the calculation would be 1200 divided by 100.1 multiplied by 44. This gives us a value of 527.47 million tons of carbon dioxide. So this makes option B the correct option for this question. Question 4. Titanium 4 oxide TiO2 is brilliantly white and much of the oxide produced is used in the manufacture of paint. What is the maximum amount of TiO2 obtainable from 19.0 tons of the ore ilmenite FeTiO3? So we have the ore FeTiO3 producing TiO2. So the first thing we need to do is find out the MR of these two compounds. So the MR of FeTiO3 using the ARs given comes to 151.7, and this produces TiO2, the MR of which comes to 79.9. So 151.7, and the masses used here are tons. So 151.7 tons of ilmenite produces 79.9 tons of TiO2. So the amount given to us is 19. So 19 tons of ilmenite would produce how much TiO2? So the calculation would be 19 divided by 151.7 multiplied by 79.9, and this gives us 10.0 tons of TiO2 being produced, making option A the correct option for this question. Question 5. 2.920 grams of group 2 metal X reacts with an excess of chlorine to form 5.287 grams of a compound with the formula XCl2. What is metal X? So, in the case of each of these compounds, we've got barium producing barium chloride, we've got calcium producing calcium chloride, we've got magnesium producing magnesium chloride, and we've got strontium producing strontium chloride. So now the first thing we need to do, since the AR is given, we need to calculate the MR of these four chlorides. So using the AR values, the MR of barium chloride comes to 208.3. The MR of calcium chloride comes to 111.1. The MR of magnesium chloride comes to 95.3, and the MR of strontium chloride comes to 158.7. So now the AR values have also been given. So we need the AR values as well. For barium, it would be 137.3. For calcium, it would be 40.1. For magnesium, it would be 24.3. And for strontium, it would be 87.6. So now we need to find out which of these elements will produce 5.287 grams of the chloride when 2.92 grams of the metal is used. So we need to perform separate calculations for each of these metals. So for barium, the calculation would be uh, 2.920 divided by 137.3 into 208.3, because this would be mass that is used upon AR of barium multiplied by the MR of barium chloride to get the mass of barium chloride produced. So this gives us 4.43 grams, which makes barium incorrect. Next we have Calcium. So for calcium, we would perform the calculation 2.920 upon 40.1 into 111.1. So this would give us a value of 8.09 grams, which is incorrect as well. So calcium is not the metal. Next, we have magnesium. So for magnesium, the calculation would be 2.920 upon 24.3 multiplied by 95.3, which gives us a value of 11.45 grams, which is also incorrect. And finally, we have strontium, which should be the correct answer, but let's calculate the value. So for this, the calculation would be 2.920 divided by 87.6 multiplied by 158.7, which gives us a value of 5.29 grams. Now, 5.29 grams is what we have obtained. 5.287 grams is what is given. So if we round 5.287 to the nearest two decimal place, this becomes 5.29 grams, making option D the correct option for this question. Question 6. Which mass of solid residue can be obtained from the thermal decomposition of 4.10 grams of anhydrous calcium nitrate? So, when calcium nitrate decomposes, it produces the only solid calcium oxide. The other products are gases, nitrogen dioxide gas and oxygen gas. So, here we are concerned with the solid residue produced. So first thing we need to do is calculate the MR of these two compounds. So using the AR data provided, the MR of calcium nitrate is calculated to be 164.1 grams, which produces calcium oxide having an MR value of 56.1 grams. So if we had 4.10 grams of calcium nitrate, how much calcium oxide would be produced? So the calculation would be 4.10 divided by 164.1 multiplied by 56.1, giving us a value of 1.40 grams. So this makes option C the correct option for this question. Question 7. Lead 4 chloride will oxidize bromide ions to bromine. The Pb4 positive ions are reduced to Pb2 positive ions in this reaction. If 6.980 grams of lead 4 chloride is added to an excess of sodium bromide solution, what mass of bromine would be produced? Okay, so here we have a reaction in which lead 4 chloride, which is PbCl4, is reacting with an excess of sodium bromide to produce bromine, Br2. And these are the two compounds that we are concerned with. So the first thing we need to do is calculate their MRs. So for PbCl4, the MR is calculated to be 349.2, and for Br2, which is diatomic, we have the AR of bromine as 79.9 multiplied by 2 gives us a value of 159.8. So these are their MR values. Now, the question asks us if 6.980 grams of PbCl4 is used, how much bromine would be produced? So the calculation would be 6.980 upon 349.2 multiplied by 159.8. This gives us a mass of 3.19 grams for bromine. So the answer that has this value is present in option C, making C the correct option for this question. Question 8. 560 kg of nitrogen and 120 kg of hydrogen are pressurized, heated, and passed over an iron catalyst. When the mixture of gases reaches equilibrium, it contains 96 kg of hydrogen. Which mass of ammonia does it contain? So the equation for this reaction would be N2 plus 3H2 giving us 2NH3. So we are comparing the masses of hydrogen and the production of ammonia. So the moles of hydrogen that will be used would be 2 into 3 is 6 moles here, and this produces ammonia 14 plus 3 17, 17 to the 34. So we have production of 34 grams or kilograms in this case of ammonia from 6 kilograms of hydrogen. So how much hydrogen was actually used up? Out of the 120 present, 96 was present at equilibrium. That means when we subtract these two values, we end up with a value of 24 kilograms, which was used during the reaction. So 24 kg would produce how much ammonia? So this would be 24 divided by 6 multiplied by 34, giving us a value of 136 kilograms of ammonia being produced, making option C the correct option for this question.